Hello everyone. Myself Dr. B. Srimati, Assistant Professor of Physics, Sita Lakshmi Ramaswamy College, Tiruchirappalli. The topic of today's lecture is piezoelectricity. In this lecture, we will be discussing about piezoelectricity, the different types of piezoelectric effect, and different available piezoelectric materials and their applications. So, what is piezoelectricity? The word originates from a Greek word piezo, which means to press. Whenever a material is subjected to a mechanical pressure, then the electrical charges get accumulated on the surface of the material, and this effect we call it as direct piezoelectric effect. That is, the pressure that is applied, it is getting converted to electricity. And this effect was discovered by Pierre Curie in quartz crystals in the year 1880. When there is no stress applied on the material, then there is no generation of electricity. When we apply a tensile stress on the material, then the electricity generation occurs in the same direction as the application of the stress. When we apply compressive stress, then electricity generation occurs in the opposite direction. Similar to direct piezoelectric effect, we have inverse piezoelectric effect, which means the application of electric field results in the generation of strain, which means that when an electric field is applied, then the material gets displaced and either it is expanded or contracted. For example, if we apply an voltage which has same polarity, then the material expands. If we apply an voltage that has an opposite polarity, then the material contracts. This is an example of how a piezoelectric effect will work. Now, moving on to the materials which are available in nature as well as man-made materials, that is, synthetic materials. The natural materials of piezoelectricity include quartz, topaz, rochelle salt, sucrose, silk, and dentin. The synthetic materials are lead zirconate titanate, zinc oxide, barium titanate, lead titanate, potassium niobate, and sodium tungstate. Now, we will discuss about the applications of piezoelectric materials. These piezoelectric materials find applications in power generating sidewalks and highways. The power generating sidewalks are places where when the people move on the piezoelectric materials, then the charges get accumulated on the surface here and the pads here get charged under the crosswalk and they collect the energy from these vibrations and these are stored as energy in the batteries. For example, in France, these piezo sidewalks power a town's street lights as people walk over the piezoelectric material. And also in Israel, cars driving over the piezoelectric elements in a highway power a nearby small town. Gyms and dance floors can be laid with piezo crystals under the floor or tiles. This energy can be used to power the equipment in that place. Also, the piezo crystals laid under keys of mobile unit and keyboards produce piezoelectric effect. For example, for every key we press, vibrations are created and these vibrations can be used for charging purposes. So here is the overview of what we have seen so far. Generation of electricity through pressure is called piezoelectricity. The material that generates electric charges when it is subjected to mechanical pressure is called direct piezoelectric effect. Material that undergoes expansion or contraction when subjected to electric field is called inverse piezoelectric effect. And there exists natural as well as synthetic piezoelectric materials. Piezoelectric materials find energy harvesting applications in gyms, mobile keypads, keyboards, dance floors, pathways, highways, and so on. Thank you.